So today is Friday, September 22nd. We still have the last page of 3.4 that we haven't finished. And after we finish 3.4, I would like to have a little review about what we learned in chapter 3, and we will play a Kahoot game, and then we will start 4.1. Do you have 4.1 handouts? Okay. So our exam is next Friday. Okay, so our exams only cover chapter 3. So even though I want to give you 1 week to study for the exam, but in this 1 week we still need to cover new stuff. Okay, and the homework 3 and quiz 2 is due Monday, and then I will do a quiz on Tuesday. We can look at the quiz 2 mistakes on Wednesday. Over this weekend, please do the practice exams. I will show you what the practice exam is. Okay, so first of all, let's finish the session 3.4. Okay, so last time we talked about the definition of derivative. Derivative is the slope of the tangent line, right, everybody? And this is the formal definition of derivative. If we have 2 points, right, and the first point we call it x, and the second point we call it x plus h, and we let the second point get it close to the first point. That's why we have the limit h goes to 0, and then this is the slope of this line. Right, everybody? If you draw the picture, then you can write down the formula. We understand it. You don't just memorize it, but understand it. And so change of y over change of x. That's why the numerator is, let me turn off the second. Okay, sorry, more space. Okay, so change of y is f of x plus h minus f of x, and then all over h. And all of these are notations of derivatives. And all these are notations of derivative at a particular point. Okay? And last time we also did example 3. We start with the definitions. Right, everybody? And f of x plus h is, you look at the formula of f. Whenever you see x, replace x by x plus h, right? And we also distribute and we get this one. So if you try to plug in h is 0, you get 0 over 0. When you see 0 over 0, that means there is a bad guy. So, and because we have difference of square roots, we multiply by its conjugate. Right? The conjugate is the same 2 terms, but the middle sign changed from minus to plus. Right? And when you multiply by the conjugate, make sure you multiply on the numerator and the denominator. And then a minus b times a plus b is a squared. That's why we get rid of the square root. Minus b squared. And denominator, we have h, and also this term, right? Last time I almost forgot to put this term. Yeah, do you remember? So we gotta be very, very careful. And we distribute this minus sign, it changes to minus. So the 3x cancel, the 5 cancel, we have the 3h. Now, you see the bad guy? The bad guy is h. It makes the numerator and denominator 0. We cancel the bad guy, and then we can plug in h is 0 again. H is 0, we realize this term and this term is the same, right? Therefore, this term plus this term, they are the same. That's 2 copies of this term. Okay, so this is the answer. And the derivative f prime of x would be a function of x. Okay? If the problem next, they want you to find, okay, what is the tangent line at x equals 1, something like that. Okay, so maybe part A, they ask you to find the derivative using limit definition. Part B, they want to ask you to find the tangent line at x equals to 1. But what do? The m tangent will be, so yeah, it would be the derivative at x equals 1, right, everybody? And you don't need to do this thing again. Just plug in x is 1 here. Okay, this is the derivative. Okay, so you plug in x equals 1, you get 3 plus 5. Right, everybody? So you get 3 over 2 and square root of 8. Do you know square root of a is 2 root 2? Yes. And I can multiply by another copy of root 2. Then your denominator, you can get rid of the irrational number, right? So root 2 times root 2 is 2. And you have 3 copies of 2 multiplied together, you get 8. This is the slope, right, everybody? To find the tangent line, you need the slope, and you also need the point.
What if you leave the rational in the denominator?
This?
No, like
this?
Instead of multiplying.
That's okay. You're still correct. Okay, I'm not too picky about simplifying. Okay, if the problem didn't ask you to simplify, it's okay to not simplify. Yeah. And then you also need the point, right? The point, we know the x coordinate is 1. The y coordinate will be, you plug in 1 into the function, right? The function is square root of 3 plus 5. So square root of 8, okay? Which is 2 root 2. So this is 2 root 2. That's the point. Okay. Is that okay, everybody? We know the point, we know the slope, so point of form. Y minus the y coordinate of the point equals the slope times x minus the x coordinate of the point. Okay? And therefore, y equals, I can move this to the other side, and I can also distribute. So we get 3 root 2 over 8 x minus 3 root 2 over 8. And then this guy, when you move to the right, it becomes positive. Is that okay, everybody? Oh, actually, you can also simplify this. This is like over a, and then you multiply by a. You get 2 times a is 16. 16 minus 3 is 13. So this is 3 root 2 over ax plus 13 root 2 over 8. So this is the tangent line. Okay? So in the exam, I'll also ask you a problem like this. You have 2 parts. Okay? You find the derivative. Okay? In general, it's always a function of x. And then part B, you need to find the tangent line at a particular point. So you find the slope, which is you plug in a number into the derivative, you get the slope. And you need the point. So you plug the x value into the function, you get the y coordinate of the point. Then you use point slope form. Do you need to take a picture of this? I know it's not in your worksheet, but your exams will have some problem like this. Yeah, feel free to come closer. Maybe I should do it on the screen, then it's in the recording. Sorry about that. Okay. All right. Next time I will remember. Huh? Oh.
Your timer went off.
I just turned it off. Yes. Thank you. Okay. All right. Relation between continuity and differentiability. Okay, so this is the theorem. F is differentiable at A, then F is continuous at A. Okay. Contrapositive version. If F is not continuous at A, then F is not differentiable at A. Okay, so have you learned like logic before about like statements, contrapositive statements, converse statements? If you didn't learn it, it's okay. Let me tell you. So this is okay. Implies conditional proposition. P implies Q. So we have statements P and Q. The converse statements will be Q implies P. Is that okay, everybody? The contrapositive statements will be not Q implies not P. Is that okay, everybody? Ooh, let me erase this. Okay, so we have statement P implies statement Q. The converse is you switch the order. That's converse. The contrapositive is you switch the order and you put a not there. Okay? And we have a fact that the statements and its contrapositive statements are equivalent. So P implies Q is true, then the not Q implies not P is also true. So those two statements, they're either both true or both false. Is that okay, everybody? Mm-hmm. Have you? What's in front of the P and Q? Oh, that's not. So in logic, this means not. Okay, so not Q, it means, okay, so look at this picture. F is differentiable at A. That's the P. Then F is continuous. So Q is the statement. F is continuous. So the contrapositive is not Q. So F is not continuous at A. Then, okay, then not P. F is not differentiable at A. You see, everybody? So we switch the order and we put not in front of them. Okay. So this is the contrapositive statements. They are equivalent. So that's why we have two versions. Okay? Differentiable implies continuity, and if it's not continuous, then of course it's not differentiable. We mark the converse. It's not true. Okay? If you just switch the order, it's not true. Continuity does not imply differentiable. We saw the example, absolute value of x. Do you remember absolute value of x, that example? On the right side, we have the slope is 1. On the left side, we have the slope is -1. So it's not differentiable at x equal to 0. Do you remember that, everybody? So this is an example. It's continuous. Right? Continuous means you just draw it without lifting your pencil from the paper. Okay? This is continuous, but it's not differentiable. Your left side derivative and the right side derivative do not match. So the derivative does not exist there. Okay? Derivative is just like the limits of change of y over change of x. So your left side limit and right side limit do not match, then the limit does not exist. Okay? All right, so when is a function not differentiable at a point? So we have three types. Okay, first type when the graph has a corner or kink in it. So like this, then you see your left side derivative and the right side derivative do not match. Okay, the slope does not match, right? So in this case, it's not differentiable. To be differentiable, your functions should be very smooth. Okay. This is not differentiable. Okay, second type, when it's not continuous. Well, do you remember what the problems not continuous? We have the removable discontinuity. We have the jump discontinuity. We have the infinite discontinuity. And we also have the essential discontinuity, right? So not continuous, then it's not differentiable. Okay? So second type is when it's not continuous. The third type is when the graph has a vertical tangent line. Do you remember for the line? We have this. Yes, everybody? And this m is positive, this m is negative, this m is 0, this m is undefined. And your derivative is the slope of the tangent line. That's why if your function, okay, if your function looks like this, do you see it? You have a vertical tangent line. Vertical tangent line, the slope is not defined. That's why it's not differentiable. Okay, so we have these three types. Either we have a corner, okay, then the left side derivative and right side derivative do not match. Or we have a discontinuity, okay? Or we have a vertical tangent line. Okay, everybody? Mm-hmm. Good. Okay, so yes, so this is the picture. Okay. All right. Next time, we also talk about if I give you a function, how do you find its derivative? How do you draw the derivative? Do you remember, everybody? We look at, so imagine roller coaster. Here, the slope is negative, and here the slope is 0. Slope is positive, slope is 0. So you find the point when the slope is 0, then you know for the derivative, because slope is 0, you have the x-intercept. Right, everybody? So draw the x-intercept, okay, when you have slope is 0. And then when you connect those points, imagine if your slope is negative, then your graph will be like below the x-axis, right? And if your slope is positive, you lie above the x-axis, okay? And like this number, 1.5, you can plot the 1.5 here for this point, and then you can draw it. Now it's your turn, okay? Match the graph of each function with the graph of its derivatives. Okay? Just like how I told you, imagine where your slope is 0, draw the x-intercepts. Okay?
I have a question.
Yes.
My paper was A and C. I don't see it.
So, see here? A, B, C, D.
Oh, these.
Yes.
Oh,
See. Mm-hmm. Good. So, like this. You first find one where this slope is 0.
yeah.
Can you find where the slope is 0? So, Here the slope is negative. It's the y coordinate is 0, but it's not the slope is 0. The slope is 0 is when actually the turning point is the minimum or the maximum. So can you see here? What's the tangent line? Here. Do you see the slope is positive? So not that much. This point.
Oh.
See? This is the point. The slope is 0. Then you plug the point here. And then this piece, what's the slope? Positive or negative? Yeah. So it's below the x-axis. Here, what's your slope? Positive or negative? Yeah. Here, what's your slope? Yeah. Look at which picture looks like this. Yeah. You're welcome. Very good. This point is 0, so we know the derivative point is 0. And this point is 0, then we know the derivative tell me this means negative. So it's going to how does it positive oh, which picture looks like that? Yes. So here, yes, this is your point right. And look at this. Is your slope positive or negative? Negative. So it's wrong. And here was your slope? Positive. Here was your slope? Negative. Which picture? On this side, or so positive. This side has positive. This side, negative. Oh, which picture look like this? Yeah. Okay. So, where the first you find a point where the slope is 0. You see the slope is 0 here. So you write down the corresponding x-intercept. And then here, the slope is positive or negative? Negative. Oh, x-axis. This side, where's your slope? Positive. So it's right? So here. Oh, three pictures look like this. Two. Good. Okay, so let's check our answers again. So we first find where the points has 0 slope. Okay, so 0 slope is usually happens in the maximum or minimum, right? And we draw the corresponding x-intercept. And then on the left, slope is negative, so we know it lies below the x-axis, right? And then between the slope is positive, so above, and then here slope is negative. So do you see is number 2, the picture? Okay, part B. Do you see here the slope is positive and is a number, right? So that's why here we have a constant, some number positive, right? And then from here to here, do you see the slope is negative? So we also get a constant. Why do I put an open circle here? Because at this point, your left side slope and the right side slope do not match. Right, everybody? So it's not differentiable at that point. So that's That's why the derivative is not defined. Okay? So we put an open circle here. And then here, do you see the slope is positive? And it's a positive integer, right? But might not be integer, but positive number. But it's a constant. So constant function, horizontal line, right? Sorry, say that louder. Oh, sure. Okay, so we look at this piece. Do you see it's a line? So the slope is a number, and the slope is a positive number. So it is a constant. So positive, it means it's above the x-axis, and it's constant. You know, constant function is a horizontal line. The y remain the same. And then once you get to this point, you put an open circle. Because from here to here, the slope is negative. It's a negative number. But here you put open circle because at this point your left side derivative and the right side derivative do not match. So this point is not differentiable. Okay, so it's not differentiable, that's why we put open circle there. Because the derivative does not exist there. And then here your slope is positive, so it is a positive number. Okay, so you just keep going. That's why we have the fourth picture. So line then is a fixed number. Okay. Part C. Do you see here the slope is 0? And on the left, your slope is positive or negative? Negative. Do you see when x goes to minus infinity, your slope is going to 0? Because it's more approaching to the horizontal line, it's more flat there. So that's why this is negative but goes to 0. Okay, so negative but goes to 0. Okay? On the other side, your slope is what? Positive, but it also goes to 0. Right, everybody? Okay, so it's positive and also goes to 0. That's why it's the number 1 picture. Okay. D. You find where the slope is 0. So here, here, here. And on the left side, this piece, your slope is negative? Positive, yes. So it lies above the x-axis. And then this piece, the slope is negative, so below the x-axis. Next, this piece, positive, so above the x-axis. And then finally, what? Negative, so below the x-axis. Which picture look like this? 3. Okay, everybody? So now I can give you the graph and you can draw the graph of the derivative. Okay, continue. Example 7. State the number at which the following function is not differentiable. And you can also need to tell me which type. Okay, look at the first picture. Let's look at from the left to the right. So imagine we go. Ooh, is it differentiable here? No. So this is x equals to what? Negative 4. So x equals, x equals negative 4 is not differentiable. But which type? Is a corner? Is this continuous? Is this continuous or is a vertical tangent? Corner. And then keep going. 2. Oh, is it differentiable here? No. This is at x equals 0. And which type? Yes. It's not continuous. And can you also tell me which discontinuity? Jump, yes. Jump. Discontinuity. Is that okay, everybody? Mm-hmm. And then we go here. Let's imagine this one. No, okay, let's imagine the tangent line is like this. So it's not really vertical. Okay, so let's forget about this part. So it's not quite vertical. Okay, so keep going. Second picture. From the left to the right. Here, go. Oh, what happened here? Yeah. So this is x equal to 0. Which type? Yeah, not continuous. And which type of discontinuity? Essential is this one. This one? Infinite, yes. Infinite discontinuity. Okay, everybody? Huh? Yes, vertical asymptote. So we go to infinity. So infinite discontinuity. Okay? So what are the discontinuity types again? Removable, right? Jump, infinite, and essential. Okay? Alright. And then we keep going. Oh, what did you say this one? This is x is 3, right? Which type? Corner. Okay, good. And then, yeah, keep going. All right, picture 3. Picture 3. So right here, go. Do you see here we have a vertical tangent? Can you see that here we have a vertical tangent? Yes, this one is more obvious as vertical tangent. So we can draw a vertical tangent line. X equals -1, so it's a vertical tangent. Okay, and then we go. Okay, here x equals to 4. Which type? Corner. And that's it for picture 3, right? Picture 4. X equals what number? -1. Which type? Discontinuity. Which type of discontinuity? Jump. Okay. And then what number? 2 is a corner. Yes. Very good. So we can look at the picture and figure out the exercise where it's not continuous, not differentiables. Okay. All right. So that is session 3.4, and that is everything that will be on your exam 1. Okay, your exam 1 is from 3.1 to 3.4. Okay, everybody? All right, so let me close this. Oops, and close this. And so this is our course website. And then you go to the bottom. Do you see here practice exams and solution? Okay, so self-assessments includes practice exams, exam corrections, and records. So it's 5% of your total grade. Okay, so what do is if you can print this out and then you can work on it. So your actual exams is similar to this. So I will ask you similar type of problems. But I don't guarantee they have the same difficulties. So maybe the problem on your exams might be harder, okay, or might be easier, but it's about the same type of problems. So you can use this as a study guide. Okay, everybody? So problem 1 is, well, given the picture, and then you can evaluate the function, and when you evaluate the function, Be careful with the open circle and solid circle. Open circle means no, yeah, right. Exclude the endpoint. Solid circle means yeah, I mean include the endpoints. Okay. And so for function, if we cannot find a number, what terminology do we use to describe it? For function, if we don't have a number there, we say undefined. For limits, if we don't have a number to describe it, then what do we say? Does not exist, D-E-N-E, okay? But if your limits go to infinity, then you say infinity. If your limit goes to minus infinity, then use minus infinity. But if one side goes to infinity, the other side goes to minus infinity, you say what? Does not exist. Because the two-side limit does not match. Okay, everybody? Mm-hmm. All right. So that's the first problem. Okay. And you're right. You also need to state the x values when it's non-continuous, right? Okay. And then this one is we use the limit laws. We move the limit inside with each of the functions, right? And then we plug in these numbers. But for exponential function, you know when you plug in -1, x is -1, you get e to the 0. What's e to the 0? 1. And also log, okay, so be able to calculate log. Okay, so if you have other base, then, so keep in mind, if you have like log 3 to the 5th, what do you get? Log and exponential function, yeah, they cancel, you get 5. So some log properties. Okay. All right. And then this problem is give you a lot of information and you need to sketch a graph that matches this. Do you remember when x goes to minus infinity and your y goes to -2, you draw one pair of dots there because you don't know whether you will connect the top or the bottom. You will see at the end which one makes more sense. Okay? But you know that is a horizontal asymptote. And then here, that number, then you can see from the left or right. So it's usually 4 directions. Everybody, it's either left, and you go to infinity, that's left upper corner. Put a flat there. Or left, where your y goes to minus infinity, so left bottom corner, right? Or the right, and then x goes to infinity, so right top, or right bottom. So you draw the dots, and then you can connect all the points together. Okay? Mm-hmm. And this one, evaluate the limits. When you see difference of square roots, what do? Multiply by the conjugate. If you see polynomial, what do? Factor. Hopefully you can see the fact that after you simplify it. Okay? So you cancel it again, and then you can plug in the number again. Okay, so here, how about this problem? You plug in 2 first. If you get a good number, then that's the answer. If you get 0 over 0, then that guy. So in this case, you probably need to factor the numerator and the denominator. Okay? To see if you can cancel it back out. Oh, but when x goes to infinity, do we factor? No, we don't factor. If x goes to infinity, remember, if you have a lot of money, you don't care about a penny. You only care about the dominant terms, right? So dominant terms is the highest power term, which is this guy, right? In the denominator, the dominant term is this guy. Remember I said in the exam, if you want to use this shortcut proof, you have to write down D and T, dominant term of the numerator. Sorry, DTN, after you say it aloud. Okay, and DTD, dominant term of the denominator. Okay, you write it down, and this limit will be just the limit of dominant term of the numerator over the dominant term of the denominator. Then you can cancel the x and you can get a number. Is that okay, everybody? All right. How about here? So find the x values for which the function is continuous. Continuous. Remember all the functions we learned are continuous on the domain. So this problem is the same as to find the domain. And for domain, we look at three things. Remember? We use these square roots. If yes, then you need the things inside the square roots to be greater or equal to 0. Do you see fraction? If you see fraction, you need the denominator cannot be 0. Do we care about the numerator? No. The third one is ln. And we need the things inside the ln to be positive. Okay, everybody? Square root, what's the picture of square root like this? So it could be 0. But ln is when you go to 0, it goes to minus infinity. So your domain does not include 0. Okay? All right. Yes, so you will get some inequality and you solve the inequality, and then you can draw the inequality, right? Exclude some points, and then express your answer in the interval notation. Okay, and see here, remember cosine, sine, continuous everywhere, exponential function, continuous everywhere, right? So this is what? Is the denominator as problem. Okay. And then this type of problem is you want to find the case such that the function is continuous everywhere, right? So you look at where do they meet? They meet at x equals -3. So you compute the left side of the limits and you compute the right side of the limits. You set them equal, okay? And you also need to figure out what is f of -3. Okay, so you have to say that equals to f of -3. Do you remember I said if you forgot to write the limit every step, you will lose 1 point. If you forget to mention f of the -3, you will lose 1 point. Okay, everybody? Mm-hmm. Yes. So do these problems. Once you finish, you can look at the solution and use red pen. Do you have red pen? Mm-hmm. If you don't have red pen, you can use other color pen, or you can come to my office. I have red pen. Okay. And then you become a grader to estimate your scores. So my solution, I have the solution, and I also like give you points, something wrong here. What happened to this guy? That's weird. Okay. See, I give you points, and so this problem has 6 points, and you see how many steps you arrive, and then take off how many points you miss. Okay. So you can estimate your score on every problem, and then you can estimate your total scores. So I want you to compare the total scores and your actual exam scores when I give you back the exam. Are you improving? If you're improving, good. That means you're doing correctly. So keep up the good work. And if somebody get very high score on the practice exam, but very low score on the actual exam, something wrong. We have to make a study plan, and we come to my office. Let's figure out what's wrong and how to make a study plan. Okay? So help us to improve. Okay, and then this is true or false problems. Okay, so true or false problems are challenging. Yes. So it really tests your understanding about the concept. Okay. So yes, so try these problems, and if you have questions, feel free to ask me. Okay. And this problem, we find the vertical asymptotes and horizontal asymptotes. Do you remember I compared like the method to find vertical asymptotes and horizontal asymptotes with you? And when you find the vertical asymptotes, you want to factor, right? And you find the domain, and for those numbers, you plug in the factor form. Do you plug in the original form? No. Remember your quiz? If you plug in the original form, you only get 0 in the denominator. You can't tell whether it's 0 plus or 0 minus. So you must plug in the factor form. Okay? And to find horizontal asymptotes, you let x go to infinity or minus infinity. So you look at the dominant terms. Okay? Do not so look at the dominant terms, okay? And do not look at the lower terms, okay? And then this one, average rate of change on those two numbers. So on those two numbers, because they are fixed number, you can just plug in this number into the formula and get a y value, okay? And then you can use the difference of y minus difference of x. So plug the numbers first. This is the numbers, the two numbers. But this one is very similar to the things we just learned. You use the definitions, the limit definition, to find the derivative. And then you find the sum of the tangent line at that number. So you plug that number into your formula of part A, okay? And then part C, you find the equation of the tangent line. Okay, everybody? So this is like what we just learned. Oh no, I only have 3 minutes. I hope to play a Kahoot with you. Let's see. Can we still play it? Okay, everybody take out your phone. Let's play it. And hopefully it won't take a long time. So everybody take out your phone. See? Come on, Kahoot. Why do you keep loading? Okay, here we go. Go to Kahoot.8 and enter the game pin 9443084. 9443084. Do we have everybody? Yes, everybody? Let's see. Almost. Okay, good, good. Let's start. 7 questions. Evaluate the limit. Look at the dominant terms. Okay? Look at the dominant. Look at the dominant terms of numerator. Here. Okay, so what do? Dominant term is 5x squared, and cube root of x to the 6 is x squared as well. Cube root of 8 is 2. So 2x squared plus 5x squared is 7x squared. Denominator, because of the product, you use 3x times 2x is 6x squared. So 7x squared over 6x squared is 7 over 6. Okay. Oh, okay, you didn't get it right. Good. Find the following. What is the limit? X goes to 1. Okay, X goes to 1. You see the left side limit and right side limit do not match? So the limit does not exist. Okay. Good. Classify the type of discontinuity of this function. Which type? Good job. Oh, you get this right. Okay. Which of the following function is continuous for all the x values? Which one is continuous? So which means the other three are not continuous. Which one is continuous for all the x? Two more students? Good job. Yes, good job. This one, because x squared plus 1 is always positive. So this is continuous everywhere. Here the problem is the fraction. Here the problem is square root. Here the problem is the denominator. Okay, yes. Good. Good. Okay. What is the horizontal asymptote of this function? Horizontal asymptote, not vertical, horizontal. Dominant terms. What are the dominant terms of numerator and denominator? Dominant terms. One more student. Get it? Okay, yes, very good. So 10 over 9. We look at we multiply the highest power terms. Good. Sorry, I keep you waiting a little bit. Determine if this is true. If the limits of the new f of x is 0, then the limits of f of x over g of x is 0. Is this true? Right, not true, because you can have f and g both be x. Then f over g is 1. Okay, good, good, good. One last problem. Is the following true? If the fraction is 0, then the numerator must be 0. It's false. It's actually false. Okay. Good. So third place. Mac. Paige. And have a nice weekend. So please do your practice exams and ask me questions next week. Thank you. You too. Sorry about keep you late.